Hi, Mr. Corsi here. This video has the complete detailed solutions to all the questions in the AQA Foundation Level GCSE Mathematics Paper 3 exam from 2024. Now there's a lot of questions, but to find the particular question you might be interested in, you just need to scroll along the timeline below the video. And I hope you find these solutions are useful in your journey towards success in your GCSE exam. So here we have question 1, and we're told that a village has 4 bus stops, and we're shown a bar chart of the number of people waiting at the bus stop at 3 p.m. on one day. And in part A we're told that there are 2 people waiting at the football ground bus stop, and we have to show that information in the bar chart. So let's look at a larger diagram, and there's the gap at the football ground where we have to fill in the bar, and we're told 2 people. Now there's the 2 line. Let's go along. So we would have to put in a bar as neatly as we can in this missing gap and shade it in. So something similar to that. Now you are trying to make a bar that looks similar to that. So I think we did not badly there. So let's move on to part B. How many more people were at the school bus stop than at the post office bus stop? Well, we'll need to find out how many were at each. So let's write this down. The school bus stop, let's go up that column and along. It seems to be halfway between 12 and 14. It's 5 wee squares are 2 people, so 2.5 squares would be 1 person. That's certainly halfway between the 12 and the 14. So there's 13 people waiting at the school bus stop. The other bus stop was the post office bus stop. So let's write that down, post office, and let's do the same for that. We'll go up to that height and along to read off the number of people. There's 4. How many more people are at the school bus stop than the post office? So we would take 4 from the 13. That'll give us 9. So there were 9 more people. Well, here's question 2. And we're given 4 temperatures in degrees centigrade. Here they are in this table. And we have to write these temperatures in order, starting with the coldest. Now I think to manage this successfully you have to imagine a number line. Well, rather than imagining one, here it is. We've got orange, the negative numbers, and blue, the positive numbers. So the smallest, or the coldest, if we're talking about temperatures, would be towards the left on the number line. So the furthest on the left and among these would be -7, followed by, then we come to -5, and then there's one other negative one in this list, that's the -1. So that's our 3 negative numbers put in order, and finally that leaves us with the number 3. So there's the temperatures, starting with the coldest one and moving along to the warmest temperature. So here's question 3, and we're given the first 3 terms of a linear sequence. That's 5, 11 and 17. Now the key thing is that a linear sequence means that there's a fixed number added to each term to get the next. Now you can see in this case if we add 6 to the 5 we get 11. If we add 6 to the 11 we get 17. So the rule is add 6 to get from one term to the next. So it says write down the next term. Well, we'd have 17 plus 6. And that'll give us 23. So the next term is 23. Now let's look at part B. In this case it says describe the term-to-term rule. And we've just figured that out. It's add 6. So the key is the term linear. There's a fixed amount you add on to get from one term to the next term. That's the characteristic of a linear sequence. Well, here's question 4. And we're told that Lucas spends 71 pence and he pays the exact amount with 4 coins. We've to list the coins that he uses. Now, it might be helpful to write down all the coins that he might be using. There's a 1 pence, 2 pence, there's 5 pence, there's 10 pence, there's a 20 pence, 50 pence, and we certainly don't need a pound coin because that's more than he's spending. So let's try and use 150 pence. Now what does that leave us? We've got 71 pence and we take away 50 pence. That's 21 pence. Now if we used a 20 pence, that would leave us with another 1 pence. And that would certainly make 71 pence, but it would only be 3 coins. However, instead of 20, let's split that up into 2 10 pences. So we've got a 50, a 60, a 70, 1 pence would be 71 pence. And there are 4 coins that do the trick. So an answer would be 50 pence, 10 pence, 10 pence, and 1 pence. Now, if you had tried 20 pences to begin with, there's a 20 pence, another 20 is 40, another 20 is 60. Now that would leave us 11 pence. And that's 1 more coin we've got. There is no 11 pence coin. So I don't think it's possible without the 50 pence to get a solution. So it's 150, 2 tens and a 1 pence. So here's question 5. We're asked to complete each statement. There's 1, 2, 3 statements here using one of these symbols. Now, some people tend to get confused about which is which, this one and this one. The way I like to remember it is if you imagine 2 lines like this, and you're reading this as you would read a normal book from left to right, this distance here between the lines is less than this distance here. And look at this one. If we read it from left to right, this distance here is greater than this distance here between the lines. So if you read these signs like a book, less than, greater than. And of course, the middle one is your familiar equals sign. So let's have a look at this first statement. We've got 2.54 and we're comparing it with 2.508. So certainly they're not equal. So either this is less than or greater than this. Now they both have 2 units. They both have 5 tenths. So we're down to the hundredths. This one has 4 hundredths. This one has no hundredths. and we're into the thousandth column. We've got 8 thousandths. So they both have 2.5, but this has 4 hundredths. This only has 8 thousandths, which is a lot less than this 4 hundredths. So this number is larger, greater than this number. So this would be greater than. And let's look at 0.25 and 1/4. Now you do have a calculator, so you could just go 1 divided by 4 if you don't know the answer to this. 1 divided by 4, and you'll find that that comes out as 0.25. This is 25 hundredths. And cancel by 25, you get 1/4. So these are equal. Now let's go on to the last statement. Lots of ways of thinking about this. 2 compared to 5 halves. Now, 2 can be written as 4 halves. After all, 2 halves is a 1, and another 2 halves is a 1. So 4 halves would be 2. 4 halves compared to 5 halves. This one is less than this. It's got less halves than this one does. 4 halves compared to 5 halves. This is a decimal. 2 into 5 goes 2, with 1/, for dividing 2 into 5. With 1/, 2 into 10 goes 5. There's 2.5. Or use your calculator. 5 divided by 2, you get 2.5. And now you can see that 2 and 2.5, well, there's more with 2.5 than there is with 2. There's an extra 0.5 here. So either way that you think about this, 2 is less than 5/2. Well, here's question 6, and we're given pictures of 3 solids. First one's a cube, and in part A we're asked how many faces does the cube have. Well, let's look at a little animation. So here we have a cube which I can rotate, and what I can do now is I can open up that cube like so, and then we can count all the faces. There's 1, 2, 3, 4, 5, 6. Let's put it back together again. And there we go. So you can see a cube has 6 faces. So 6 faces. Let's move on to part B. This one says, how many edges does the square-based pyramid have? Well, again, let's look at an animation for that. So here you have this square pyramid. I can rotate it, and it's sitting on a square base. Now, if we look at it from above, there's 1, 2, 3, 4 edges. Now let's look at it from below. There's the square, and there's another 1, 2, 3, 4 edges there. So that square pyramid has a total of 8 edges. So 8 edges. And finally, let's move on to part C. And this time, how many vertices does the cone have? Now, the vertices are the bits that hurt you. That's the sharp corners. And on this cone, there is only one. That's this bit at the top here. There are no other sharp points on it. So the cone has one vertex. If there's only one, it's a vertex. If there's several, they're called vertices. So here we have question 7. And in part A, we're given a number machine, input 12, couple of operations, and here's the output. We're asked to complete the number machine. So the 12 goes in, and the first operation we do on it is to take away 4. So 12 minus 4 is 8. So we've reached here with an 8. Second operation tells us to multiply by 5. Now remember, you do have your calculator in this paper, and that will give you 40. So the output is 40. And that's us completed the number machine. Let's move on to part B. Here's a different number machine. This time the input is 7. The first operation is unknown. The second operation says divide by 2, and we end up with an output of 9. So what on earth goes on? We have to fill in this unknown operation. So 7, we do something to that, and we end up with some unknown number, which, when we divide by 2, gives you 9. Well, that would be 18. You can do this in reverse. 9, if we reverse the divide by 2, we get a times 2, which gives us 18. So we're starting with 7, we're doing something unknown, and we're ending up with 18. Well, what do we add to 7 to get 18? What's the difference between 7 and 18? That's 11. If we take 7 from 18, we get 11. So let's just check that. Start with 7. First operation, add 11. Well, we get 18. Second operation, divide by 2. That gives us 9. That's what we wanted. So there's that number machine completed. So finally, let's move on to part C. And this is even more complicated. We don't know what the input is, we don't know what the output is, we don't know what the two operations are. All we know is we multiply by something and then we subtract by something. But look, down here they've told us when x is 5, y is 13. So let's follow that one through. If we start by 5, we multiply by something, we subtract something, and then out pops 13. So let's try and figure this out. If we're subtracting something to get 13, when we multiply the 5 by a number, we must get an answer bigger than 13. Well, 5 2s are 10, that's not enough. 5 3s would be 15. 15 take away 2 would give us 13. Now this may not be the answer because we're given more information, and we're going to have to check what we've found out from this first example by using the numbers in the second example. And in this second example, if you put 10 in, that's x, out pops 28. So let's see if that works. So 10 goes in. We're now saying we multiply it by 3. That would give us 30. We take away 2. That would give us 28. That's exactly what we were supposed to get. So there's the complete number machine. We multiply by 3, then we subtract by 2. That fits both the pieces of information that were given. Well, here we have question 8, and we're told the various costs of items, and we're told Dan is buying 2 packs of pegs, 1 bar of soap, and 1 basket. We're asked what fraction of the total cost is the cost of the basket. So the total cost is what we'll need to work out. Now he's buying 2 packs of pegs, and each pack of pegs is 40 pence. So 2 lots of 40 pence would be 80 pence. So the first item is 80 pence. Now, writing this down with a pounds column and then the pences. He also buys 1 bar of soap, that's £2.20. And finally, 1 basket, that's £7. So remember, you do have a calculator, so if you're challenged with this, you can do it on your calculator. Let's look at the pence. 80 pence plus 20 pence, well, that's £1. 7 and 1's 8 and 2's 10. So the whole cost of the items that is bought is £10. Now, we're asked what fraction of that total is the basket. So the basket is £7 compared with the £10 total. So the fraction would be 7/10. So let's write that in. And your working will give you the rest of the marks. You should have working showing you what you've done. Don't just keep it all in your calculator. Remember to write down as much as you can of your working. So 7/10 is the fraction of the total cost. That's the cost of the basket. So here we have question 9, and we're asked in this question to calculate the square root of 625 and then add 7 cubed, 7 to the power 3. So this is definitely a calculator question, so let's bring on the calculator. Now, the square root in my calculator, you'll have a square root, all calculators do, 625, and then we add 7 cubed. So there's 7. Now in my calculator, I don't have a cube button, some calculators do. There's raised to the power of. So I would press that, and then I get this wee index appearing. That's where my 3 goes. So that's 7 cubed, and then press the equal sign, and I get 368. Well, here's question 10, and we're told that 8,400 fans go to a rugby match, and there's various pieces of information about them, and we're given an incomplete frequency tree. We're asked to complete this frequency tree. So let's just work through the information that's given and seeing what we can do with this. So, of these 8,400 fans, 6,850 of them support the home team. There they are. Now, what can we tell? Well, we can tell that there's some that don't support the home team. They would be the ones that support the away team. So we could fill in this, because the ones that support the home team plus the ones that support the away team will come to a total of 8,400. So we should be taking away 6,850 from 8,400. So let's do that. We'll take 8,400 and we'll subtract 6,850 from that. And there we get 1,550. So in here, 1,550. So we've used these two pieces of information. Let's look at the next piece. 20% of the home fans wear a scarf. Well, home fans, 6,850. Do they wear a scarf? Yes. So in here would go 20% of 6,850. So 20% be 20 divided by 100, that's what 20% means, times 6,850. Now we have 1,550 370. Now that would mean that the ones that don't wear a scarf of these fans would be the difference between 1,370 and 6,850. So we take 1,370 away from 6,850. 6,850, and we'll subtract 1,370. There we have 5,480. So that's us used that piece of information. Now, we're told now that 2,319 of all the fans wear a scarf. Now, where are the ones that wear a scarf? Well, there are these ones and these ones. Because of the home fans, these are the ones that wear a scarf. Of the away fans, these are the ones that wear a scarf. And we're told that the total of these two is 2,319. So 2,319. So to find this, we'll take the difference between 2,319 and 1,370. 2,319 minus 1,370. 949. So that's the total number that wear scarves. It's that 1,370 plus that 949. So that's us used that. So there's only one number now missing from the frequency tree. 1,550 away fans, 949 wear a scarf. How do we work out the number that don't? Well, again, that's a subtraction. We'll do 1,550 minus 949. So that's 1,550 minus 949. And that seemingly is 601. Let's do a final check, because if we've got all the fans, then the total of these four numbers here should come to 8,400. So just to make sure that we haven't made a mistake, let's do that. Let's add up these four numbers. So there's 1,370 plus 5,480 plus 949 plus 601. Fingers crossed. There we go, 8,400. So we've double checked. That seems to have worked. So there's the completed frequency tree. So here's question 11. And we're given an x and y axis, and there's a triangle, right-angled triangle, drawn. And in part A, we're asked to work out the coordinates of point B. That's an x and a y coordinate they're wanting. So let's look at a larger diagram. And here it is. So let's start at the origin. Now remember, the first coordinate, the x coordinate, is your left and right one. And if you're going to the left, you're going negative. So 2 squares to the left, that would be negative 2. And remember, the y coordinate, the second coordinate, is the up and down one. If you're going down, then you're going negative. So we have to go 1 down. So the y coordinate will be negative 1. So your answer to the coordinates of B, we fill in negative 2, negative 1. Let's move on to part B. And we're told that point C is reflected in the line x equals 6. Now there's the line x equals 6. All the x coordinates of the points in this line are 6. You have to go 6 along from the origin to the right to get to any point on this line. That's why it's called x equals 6. And we have to work out the point D coordinates, where D is the image of C if this was a mirror line. So let's first of all make that an active mirror line, and just to show you that it's active in my diagram, I'll draw on one side, and you can see whatever I draw on one side of the line is copied or reflected in the mirror line x equals 6. So this is an active mirror line now. So let me take point C, and looking into that mirror, it's the same distance at right angles to the mirror out the other side. So there is the mirror image of the point C reflected in the line x equals 6. So how do we get the coordinates of this point? Well, again, let's start at the origin. This time we're not going left, we're going to go right. So that's positive 1, 2, 3, 4, 5, 6. That's that mirror line. 7, 8. We have to go 8 squares to the right of the origin. And how far down do we go? Well, it's 1 down, so it's a negative 1. So the coordinates of that point D, 8, negative 1. So here's question 12. And we've got Liz, who records the distance of some runs and the time each run takes. On the top row we've got the distance that she ran, and in the second row we've got the time in minutes that she took for each of these runs. And she's made up a scatter graph of this information, where up the y-axis is the time, and along the x-axis, well, we don't have a label, so presumably that would be the distance. And we're asked in part A to complete the graph by adding the missing label and plotting the 2 missing points. Well, let's have a look at the diagram, a larger version of it. So the first thing is the missing label, and since we've got time in minutes on the y-axis, along the x-axis we'll have distance in kilometres, so that should go in. Distance, and we'll put the units, kilometres. And just to check what's going on the time axis, we'll notice there's 5 little squares from 10 up to 15. Each little square must be 1 minute. So in particular for the 3 kilometre run, she took 10, 11, 12, 13, 14 minutes. Let's just check that. 3 kilometres, 14 minutes. So that ties up with the first entry in the table. And we have to plot the 2 missing points. Now we've got 2, 4, 6 altogether. 1, 2, 3, 4, 5, 6. Let's check the last one. It's 7 kilometres, 31. There's 7 kilometres, 30, and 1 square makes 31 minutes. So it's these last 2 entries in the table that we have to complete. So the second last entry, 8 kilometres, 38 minutes. There's the 8 kilometre line. There's the 30 minutes. We have to do 35, 36, 37, 38. So that's at this point here. That's 3 squares above the 35, or 2 squares below the 40, and make sure it's on the 8 kilometre line. And we'll do a similar thing for the 8.5 kilometre run, which is 42 minutes you took. So 8.5 would be halfway between 8 and 9. So in this case, there's 5 squares, so 2.5 squares would be the appropriate one. So I'm up at 2.5 squares on the 40 line, 41, 42. So it's at that point there that I put my cross. And that's the completed scatter diagram. So let's look now at part B. And here we have to describe the correlation shown in the scatter graph. That's this scatter graph. What type of correlation is it, and what's the strength of the correlation? Well, let's have a wee recap of what types you can get and what strength of a correlation means. So here's a little table showing you this. The correlation, this is a relationship between two variables shown in a scatter graph. Well, the two variables are distance and time in this case. Type of correlation, you can get a positive, a negative, or there may well be no correlation at all. And we'll see what that means in a second. The strength of the correlation, you can either have strong correlation, weak correlation, or none. And it says it's based on how closely points follow a straight line. Well, you can see these certainly follow a straight line. We can imagine a straight line. They're not quite on a straight line, but they look pretty close to a straight line. Let's see now a picture showing these ideas. So positive correlation would be when one variable increases, the other variable also increases. So it's an upward sloping straight line. There's no correlation in the middle. There are random points all over the place. Negative correlation would be when one variable increases, the other variable decreases. That's a sloping down straight line. Strong, very tightly gathered around a straight line. Weak, they're more scattered around a straight line. No correlation. There's a weak negative. They tend to go down the way, but they're loosely gathered around a straight line. This is strong negative correlation. They're going down the points and they're very tightly gathered around a straight line. So in this picture that we've got, the type would be positive. They're certainly going uphill. So that's the type of correlation we could say is positive. Now, is it strong or is it weak? I think it's fairly strong. They're quite tightly packed around an imaginary straight line that's going up there. So we'd say that's a strong positive correlation. So this is question 13. We're told in this diagram AB is a straight line, and we seem to have two angles meeting at this point here. In this one we've got 3 angles meeting at this point. Now we're asked, is y, size of this angle, a half of x? That's the size of this angle. Yes or no? Well, obviously for 3 marks we're going to have to put working that justifies the choice that we've made. So first of all, I want to take this second diagram here and look at an animation of the situation. So let's have a look at that now. So here we have a diagram showing 3 angles around a point. Now in this diagram we can move the arms of the angles And we've also got a calculation at the bottom showing the sum of the three angles. And you can see that every time I move this, one of the arms, the total is always 360. So three angles around a point, 360 degrees. That would be true if there were 4 angles or 5 angles. The sum of all the angles around a point is 360. Now in this example we've got a 90 degree angle and we've got 163. We should have 107 for the third angle according to this diagram, but we'll have a look and see how we can calculate that in a minute. Now again, in a similar way, let's have a look at the first diagram here and we'll do an animation for that. Now in this diagram I have a straight line along the bottom with a point in the middle, so it forms a straight angle of 180 degrees, and I've put a vertical line up from this point. So two 90 degree angles on each side. Now, if I increase the angle on the left, the angle on the right decreases by the corresponding amount. And we end up with the sum of these two angles always being 180 degrees. There's our 90 degrees on either side. Let's do it on the opposite side. Both of these angles add up to 180. They're called supplementary angles. So let's tackle the value of x first. Now in the animation you saw that the three angles around a point add up to 360. Now we already know two of these angles. There's a 90 degree angle, the right angle, and there's 163 degrees. So we would have to take both of these away from 360 to find out what was left. In other words, to find what x is. So x we would get by taking 360 degrees minus the 90 and then minus the 163. 360, we're subtracting 90 and we're subtracting 163, and that equals 107. Now I think that's what we suspected from our animation, that was 107. So x is 107. Let's now tackle y. And remember in the animation we saw that the two angles around a point on a straight angle add up to 180. So to find y, we would take the 127 away from 180. So let's write down our working there. Y would be 180 minus 127. Here's 180 minus 127. And that equals 53. So y equals 53. Now, the question asks us, is y a half of x? Well, let's work out a half of x. So 107 divided by 2 and we get 53.5. Now, as you can see, 1/2 of x does not equal y. These two numbers, 53 and 53.5, are not equal. That sign means not equal to. So is y a half of x? No. Show working to support that answer. There is your working. So finally, let's look at a completely different method of solving this problem. So if we take diagram 1 over here, we know that these two angles add up to 180. So let's just write an equation to describe that situation. And you know, to solve equations, you need to keep them balanced, and you do the same to both sides. So if I want to get y on its own, I do the opposite, or the inverse of adding 127. So I'd be subtracting 127 from both sides. And if I do that on the left, I get y on its own. And if I do that on the right, then I get 53. You do that on your calculator. And similarly, if we take the second diagram, we know the three angles around a point add up to 360. We've already discussed that. So let's write an equation to describe this situation. We've got the angle x plus 163 plus that 90, giving us 360 degrees. Now, the 160 and the 90 are both on one side of the equation, so we can add these together and get 253. And again, remember, you can use this on your calculator. Now we do the same. We balance both sides by taking 253 away. And why are we doing that? Because that disappears, the 253 disappears, and we're left with x on its own, and we take 253 away from 360, and that gives us, check that in your calculator, 107. And again, we say, is y a half of x? So in this case, we would divide both sides by 2. And discover that a half of x, or x over 2, is 53.5. And again, it's clear that x over 2 does not equal y. So the answer's no. And the working are these two equations that we've solved to prove that. So here's question 14, and we're asked to multiply out 3 lots of 2x plus 8. Now let's remind ourselves, 3 lots of 6, that's short for 6 plus 6 plus 6. 3 lots of x, which is written like that, x plus x plus x. So 3 lots of 2x plus 8 would be 2x plus 8, and another 2x plus 8, and another 2x plus 8. And we're asked to find the answer to this. Now you'll notice that there's 3 lots of 2x, and there's also 3 lots of 8. So not only the 2x gets multiplied by 3, but the 8 also gets multiplied by 3. So 3 lots of the 2x would be 6x, and 3 lots of the 8, 24. Now another way that some of you might have been taught is to set the thing out in a table. Three times 2x, 6x. 3 times 8, 24. So it's 6x plus 24. So there's several ways of thinking about this problem. So here's question 15, and we've got 3 different statements with blanks in them, and we're asked to complete them. So this first one, we've got a blank plus 5 lots of x gives us 9 lots of x. Now, remember 9 lots of x means an x plus x plus x plus x plus x plus x. There's 6 of them, and another 3. That's the long way of writing out what this means. 9 x's all added together. Now on the left hand side we've got 5x, x plus x plus x plus x plus x. There's 5 of them. What's missing? Well, there must be 4 lots of x missing. And then we've got 9 x's all added together on both sides. So there was a 4x missing. 4 lots of x plus 5 lots of x gives us 9 lots of x. Let's have a look at the second one. This is a y squared. Now remember what the wee index or the power up there means. 3 squared is 9 because it's 3 times 3. 2 cubed is 8 because it's 2 times 2, that's 4, times another 2 is 8. This little index tells you the number of times this has to be multiplied together. This index tells you the number of times this has to be multiplied together. This index tells you the number of times this has to be multiplied together. So y squared, y times y. There's a y missing there. And the final one, we have a t on the right hand side. We're supposed to take away 2 t's from the left hand side to be left with 1. Well, I suppose we must have started with 3 of them, and we take these 2 away and we're left with 1. So 3t, 3 lots of t, minus 2 lots of t would give us 1 lot of t. So here's question 16, and we're buying tins of beans. We've got a choice, 2 shops, shop A, shop B. 20 tins we're buying, and we've to decide which shop is the best one, which is the cheapest shop to buy these 20 tins at. And we've also to work out how much cheaper it is in the shop that we choose. So let's have a look first of all at shop A. And we're buying 20 tins from shop A. So it tells us that 1 tin is 64p. So that's fair enough. 1 tin, 64 pence. However, if we buy 4 tins, they'll only charge us for 3 tins. Now, 3 tins would cost 3 times 64 pence. 3 times 64, 192. £1.92. Now remember, it's 20 tins that we're trying to buy. 4 tins cost £1.92. Now how many lots of 4 tins make up the 20 tins that we're after? How many times does 4 go into 20? Well, you use your calculator for that, and you'd find that we're 5 lots of 4 tins. 4 times 5 is 20. So here they all are, 5 lots of 4 tins. So what's the cost of that? Well, each 4 tins costs the same as 3 tins. So that would be 5 lots of £1.92. 5 times £1.92. That comes to £9.60. So there we go, £9.60 in shop A. So let's go next door to shop B, and we'll try and figure out how much 20 tins cost in shop B. Well, they appear to be cheaper. 1 tin costs 62 pence. However, a pack of 3 tins is £1.70, and there's a 10% reduction in price on all packs. So 3 tins, how many bunches of 3 tins will make up our 20 tins? So we're doing the same sort of problem that we did in the previous shop. How many bunches of 3 tins make up our 20 tins? Well, to do that, you would divide 20 by 3. Well, look at that. We've got 6 and a bit. So it would be 6 lots, but I think there would be some left over. So let's keep going with a little diagram here, and we'll get to 6 lots, which is what? 3 6s are 18. And that does leave us something over. 2 tins. So 6 lots of 3, 18 plus another 2, that gives us our 20 tins. Now, how much do these packs of 3 tins cost? Well, they cost £1.70 each. There's 6 of them. So the total cost there would be 6 lots of £1.70. £6 times £1.70. There we go, £10, not 2 pence, 20 pence, £10, 20. Or is it? Well, if you look at the small print here, 10% reduction in price on all packs. So reduction is 10%, that's a tenth of £10.20. Now remember, if you divide something by 10, in this case the point would move one place to the left, or all the digits move one to the right. So £1.02. And you can do that on your calculator. 10%, that's 10 divided by 100, that's where we got our tenth from, times £10.20. And there it is, £1.02. So that's a reduction. So the total cost of the packs is £10.20 minus £1.02. Well, that'll give us £9.18. You can do that in the calculator too. However, we have 2 tins. And what do tins cost in shop B? Well, they're 62 pence. So the cost of these would be 2 lots of 62 pence. Now that'd be £1.24. Again, do that in your calculator if you're unsure. £1.24. So the total cost of all the 20 tins is £9.18 plus the two that were left over, which are costing us £1.24. So that comes to £10.42. Do that in your calculator. £10.42. Let's compare it to the first shop. Well, that's more expensive. So shop A is cheaper by, so what's the difference between £10.42 and £9.60? Well, that's done on your calculator and you'll get 82 pence. So by going into shop A, you'll be saving 82 pence, even though shop B appears to be cheaper for each tin. With all the bargains that are going on, you'd be best going to shop A. You'll be saving 82 pence. Well, here's question 17. And in part A, we're told there are 30 students in a class. 12 of the students have school lunch. Now we have to work out a ratio of the students having school lunch to the students not having school lunch. And we have to give our answer in the simplest form. So of the 30 students, we have 12 that have lunch. The rest of them, take 12 from 30, do that in your calculator if you need to, 18 do not have school lunch. So the ratio students having school lunch, 12, to students not having school lunch is 12 to 18. Now, just as in fractions you can divide top and bottom by the same number, you can do that to ratios. Now, these are both even numbers. If we divide by 2, 6 to 9. Now, they're not both even, but they certainly are in the 3 times table, multiples of 3. 3 goes into 6, 2. 3 goes into 9, 3 times. So the ratio is 2 to 3, and that's in its simplest form. 6 to 9 would not be acceptable, 12 to 18 would not be acceptable because we can cancel down. We could have seen that these were both multiples of 6. 6 into 12 is 2, 6 into 18 goes 3. That would have done it in one step. So the ratio is 2 to 3. Let's move on to part B. Different class. Students wearing glasses to students not wearing glasses, 3 to 8. So we've got 3 with glasses and we've got 8 no glasses. Now this time we don't know the number of people in the class, but it's a similar type of diagram to the one up there. Suppose there was 11 in the class, 3 would have glasses, 8 would not. There may be 22 in the class, 6 would have glasses, 16 would not. We've doubled both. Or 33 in the class, multiply each of them by 3. So what fraction of the students in this class wear glasses? Well, if there was 11 in the class, 3 of them wear glasses, so that's 3 out of 11. And that would be the fraction that wear glasses. Let's move on to the last part, 17C. Now the ratio 4 to 9 can be written in the form 1, 2, and we're trying to work out what that number is. Now in this case, we're dividing by 4. So if we're doing that to this number in the ratio, to keep the ratio balanced, we must divide the 9 by 4 also. So we get 9 divided by 4. Now 4 goes into 9 twice. That's 8 with one of these quarters left over. So it's either 2 1/4 if you do it on your calculator. 9 divided by 4, that gives us 2.25. And you know that 1/4 can be written as 0.25. So 2 1/4, 2.25. Either of these would do. So that's the missing number n. Ratio 1 to n. N is 2.25. Well, here's question 18. And we're given first 3 patterns in a sequence. And in part A, we're asked on this grid to draw pattern 4. Let's examine what these are doing. We've got in the centre, let's take the largest one, pattern 3. We've got a 3 by 3 square in the centre with single squares tagged on round the outside each corner of that square. So a 3 by 3 and 4 squares at the corners. There's a 2 by 2 for pattern 2 with the 4 squares. There's a 1 by 1 with the 4 squares. So pattern 4 would have a 4 by 4 square at the centre with single squares tagged on. So let's draw that. So there's the result. Now let's move on to part B. And we're told in part B that this expression n squared plus 4 gives the total number of squares in pattern n. So let's check if this expression works for the patterns we've got. Now in pattern 1 we've got 1, 2, 3, 4, 5 squares. When n equals 1, 1 squared, that's 1 times 1, plus 4, 1 plus 4 is 5, so that certainly works. And when n equals 2, let's see, we've got 4 squares in the middle, plus 4 squares on the edges, on the corners, so that's 8 altogether. 2 squared plus 4, 2 times 2 is 4, plus 4 is 8. And final check, in the third one, 9 in the middle, 10, 11, 12, 13 we should get. 3 squared is 9, 3 threes are 9, plus 4, 13. So that seems to be working. Now it says work out the smallest value of n for which the number of small squares is greater than 500. So we want this number that we're getting here, the n squared plus 4, to be greater than 500. Or an equivalent statement, if we take away 4 from both sides of this inequality, we'd get n squared being greater than 496. Now we're dealing with square numbers here. So let's get the calculator and find out what number we need to square to get something very close to 496. In other words, what's the opposite of squaring? That'll be the square root. If we take the square root of 496, we'll see roughly where we are for the value of n. Square root of 496. Well, that's around about 22. 22 squared, let's work that out. 22 squared, that's 484. Now you can see if we put 22 in there, we would not have a number greater than 496. So let's move up one and try 23 squared. 23 squared, that's 529. And that is greater than 496. So the least value of n, so that we do get an answer bigger than 496, would be 23. So here we have question 19, and we're given a right-angled triangle, and we have to use Pythagoras' theorem to work out the value of this hypotenuse, the length of this large side opposite the right angle in this triangle. Now, let's remind ourselves what Pythagoras' theorem is all about. So here we have a right-angled triangle. There's the right angle, the two shorter sides, and then the side opposite being the hypotenuse. And this area plus this area is always equal to this area. As you can see, all these pieces in that square plus the area of the other square, they all fit exactly into this square. Now, the area of this small square would be A times A, length times breadth. That's A squared. The area of this square is B times B. That's B squared. And the area of the large square is C times C. So that's C squared. And what we just showed by rearranging these pieces was that A squared plus B squared equals C squared. So A squared plus B squared is equal to C squared. And the large square is always on the side of the hypotenuse. And it doesn't matter what the size of that triangle is, all these pieces fit precisely together so that the sum of the areas of the two small squares is equal to the large square. So that's Pythagoras' theorem. So back to the right-angled triangle in the question. Here it is. So we can now imagine the squares that are sitting on the sides of this right-angled triangle. And remember from the animation that we saw, the area of the large square, the hypotenuse squared, would be the sum of these two smaller areas. So x times x, x squared, this big area there, would be 24 times 24, 24 squared, plus 31 times 31, 31 squared. We've got x squared, this large square here, would be the sum of the areas of the two smaller squares. And that's Pythagoras' theorem that we're using there. So let's get the calculator onto this to find out what 24 squared plus 31 squared is. So we've got 24 squared plus 31 squared, and that gives us 1537. Now, in this equation, let's do the inverse process of squaring to get rid of this square. And the inverse process to squaring is square rooting. Now that would be this button on my calculator. So I'll be wanting to take the square root of this previous answer. So square root, and then I'll press the ans key. That gives me that decimal. So that's x, the square root of 1537, and that gives me 39.204, and so it goes on. Now the question says give your answer as a decimal, but it doesn't say how accurate that should be. So let's just round it to 1 decimal place. We've really vandalised that number by hacking off the rest of the digits there. So we'll say what we've done. That's to 1 decimal place. So 39.2 centimetres. So here's question 20, and Rick is claiming that most of the flats in his 8-floor building are energy efficient, and what he does is he samples 45 of the flats from floor 1 to 5 and says, look, they're energy efficient. We have to find one reason why this sample may not be useful in testing his claim. So what he's done, he's gone floors 1, 2, 3, 4, 5, and he's sampled 45 of the flats in these first 5 floors. Now what about the last 3 floors? He hasn't sampled any flats in these. So we could say that what he's done does not represent all the flats in the building. He's ignored the top 3 floors. So we could say that it's not representative of all the flats. That would be a good reason. It would be producing possibly bias. There might be things about the top 3 floors that are not the same as the other floors. So it's not representative of all the flats. So here we have question 21. And we're told that this statement here is an identity. Now you'll notice there's 3 lines here, not the normal equals sign. We're told that's an identity, and we have to take one of these boxes. That this statement is true for all values of x, it's true for some values, and it's true for no values of x. Well, first of all, we'll find out what exactly an identity means, and we'll do that by using the first few counting values of x. X equals 1, x equals 2, x equals 3, and x equals 4. And we'll try this in various statements. And the first statement would be x plus 1 equals x plus 2. So let's try x equals 1 in here. 1 plus 1, that's 2. 1 plus 2, that's 3. And certainly that statement is not true. Let's try x equals 2. 2 plus 1, 3. 2 plus 2, 4. Well, that's not so good. Let's try x equals 3. 3 plus 1, that's 4. 3 plus 2, that's 5. And again, that's not true. You can see the pattern building up. And if we work through all these statements, none of them will be true. So no values true. So that's this box down here. There's a statement where no matter what you put in for x, you'll get false statements all the time. There's no value of x which will make the statement true. Let's try another one. Let's try 2x plus 3 equals 7. And let's try x equals 1. 2 ones, that's 2 plus 3, that's 5. 5 equals 7. Well, that's not a promising start. That's not true. Let's try x equals 2. 2 twos, that's 4 plus 3. Well, there we go. 7 equals 7. That's certainly true. Let's try x equals 3. 2 threes are 6, plus 3 is 9. And there's a statement that's not true. And trying x equals 4, 2 fours are 8, plus 3, that's 11. And that certainly does not equal 7. But here we have some values that are true. So this is an example of the middle box, true for some values of x. And finally, let's try the statement 3x minus 1 equals 3x minus 3. And if we try that for x equals 1, 3 lots of 1 minus 1, that's 0. 3 lots of 0. 3 lots of 1, 3 minus 3 is 0. Well, that's true. Let's try x equals 2. 3 lots of 2 minus 1. That's 3 lots of 1. 3 lots of 2 is 6, minus 3 is 3. True again. Let's try x equals 3. 3 lots of 3 minus 1, that's 3 lots of 2, that's 6. 3 lots of 3 is 9, minus 3 is 6. And so it goes on. And you'll find that every replacement for x gives you a true statement. So all values give you true statements. And it's this last one that means this is more than just an equals here. This can be replaced by the identity sign. So if you have an identity sign in there, it means that that statement is always true no matter what value x is. That's what this one is. Always true for all values of x. Well, here's question 22, and we've got K hiring a digger, and we're told various pieces of information about the cost of hiring that digger. And if we look closely, we'll see that the first 5 days are different from the rest of the days. For the first 5 days, there's a steady charge of £24.50. Now, it'll be worth drawing these days out in a wee list, because then we'll be able to think more clearly about what's going on. So here's the first 5 days. And the cost is very straightforward there. It's £24.50 each day. So there's £24.50 for each of these 5 days. Now that immediately allows us to calculate the cost of hiring that digger for these first 5 days. So the cost for these 5 days, let's bracket these, the cost for these 5 days would be 5 lots of £24.50. That's 5 times £24.50. So in total, that comes to £122.50. So that's day 1 up to day 5. Now things get slightly more complicated. well, from the point of view of working out the costs, we're told that on day 6, the cost is reduced by 20% for day 6, and then after that, every day is the same as day 6 costs. So all these costs are the same, but they're 20% less. Now, there are various ways of working out this reduction. One of the ways is to just straightforwardly work out 20% of £24.50 and then take that away because it's a reduction. We do 20 divided by 100, that's what 20% means, and multiply the £24.50 by that. And that'll give us the reduction, which appears to be £4.90. And so the new cost would be the old cost, which is £24.50, minus that reduction, and subtract a reduction £4.90. And there we get £19.60. So every day thereafter, the cost is now £19.60. So now there is another way of doing this, perhaps a slightly easier way. We can say that that reduction is 80% of £24.50. Now let's see what's going on there. If we consider £24.50, that's what we were being charged as the whole price, 100%. If we take away 20%, that leaves us with 80%. So an alternative way of getting that reduction would be to work out 80% of £24.50. Now that should give us the same as before. That's 80 divided by 100, that's what percentage means, times £24.50. And that gives us £19.60 as before. So that's a neater way of doing that. Anyway, here we go. We've got now an unknown number of days that we're trying to work out how many days are now charged at £19.60. Now, what we do know is that they've told us the total cost of hiring this digger, and it's £259.70. £259.70. So that consists of the £122.50 for the first 5 days, and then the charge for the rest of the days at £19.60. So how much is that charge? We'll take the £122.50 away from £259.70. There's £259.70, and we'll take away the first 5 days, and that'll give us the charge for the remaining days. So we're taking £259.70 and we're subtracting £122.50. And that gives us £137.20. So in here we've got £137.20, and that's the charge for an unknown number of days, and each day we're being charged £19.60. So the question is, how many £19.60s make up £137.20? Well, that's a division problem. So the number of days would be given by how many £19.60s, how many 19.60s are there in £137.20. £137.20, and we divide that by £19.60. How many £19.60s make up this £137.20? And we get a nice round answer of 7. So there are 7 days. Now let's just look at the number of days. In here we've got 5 days, and at this lesser charge we've now worked out we have 7 days. So the total number of days will be 5 plus 7. So total days, 5 plus 7, which is 12. Days. So here's question 23, and we're shown the front elevation of a cuboid, and we're asked to draw the side elevation of a cuboid, and we're told the volume of the cuboid is 42 cubic centimetres. Well, let's have a little look at building cuboids, and let's look at their front elevations and their side elevations. So let's build a cuboid. Here's a cuboid. The front elevation is a rectangle showing 3 cubes. The side elevation is just 1 cube. Now the volume of this cuboid is 3 cubes. Now let's make a cuboid that has a front elevation similar to what the question is showing us. And there's the front elevation, a 2 by 3 rectangle. The side elevation for this cuboid has a 2 by 1 rectangle. And the volume of this cuboid, if you count the cubes, there's 6 cubes. So the volume of this is 6. Let's build another layer at the back of this. Now in this cuboid it still has the same front elevation. The side elevation is slightly longer. The volume this time, there's a couple of slices of 6 in each. There's 12 cubes altogether. So this has a volume of 12. Now let's continue with this building of another layer of 6. We've added another 6, and every time we do that we're not altering the front elevation. It's still exactly the same. We are altering the side elevation. Now the volume of this cuboid is 1, 2, 3 lots of 6. That's 18. That's not quite what they wanted yet. Let's add another 2 layers to this. Now let's check the front elevation, still the same. Side elevation's a lot longer. What's the volume of this? Well, let's count slices of 6. 1, 2, 3, 4, 5 6s are 30. Not enough. If we add another 6, that's 36. And finally another 6, that would give us our volume of 42. So there's the front elevation. there's the side elevation, which has length of 7 cubes. So the breadth is 3, the height is 2, and the length is 7. And let's confirm 1, 2, 3, 4, 5, 6, 7 slices, each with 6 cubes in it. 7 sixes are 42. So that's the side elevation that they're after. So let's draw that in now. Seven along, and 2 up, a rectangle. So there we are, side elevation. And this front elevation, you could call this the width, this the height, and this would be the length. Remember, cuboids have length times breadth times height, of length times width times height. For the volume, you'd multiply these together. Now the length of 7, the breadth or width of 3, and a height of 2. So the volume would be length times width times height. And 7 threes are 21, and if we double 21, we get 42. So that's a confirmation that we have the right side elevation and we've done everything correctly. Well, here's question 24, and in part A we're told that on Monday Lars swims 50 metres in 40 seconds. 50 metres, and to swim that length it takes 40 seconds. Now we move on to Tuesday, where he gets a burst of energy and he swims 1.5 kilometres. And we assume that he swims at the same constant speed as on Monday. So the constant speed means that we can work out 1,500 metres. Which is what 1.5 kilometres is equal to. Remember, 1 kilometre is 1,000 metres. So 1.5 will be 1,500 metres. That's 1,500 metres. So we have to work out how long it will take him to swim 1,500 metres at the same constant speed. So what we can do is to say, well, here's 50 metres, takes him 40 seconds. Suppose it was double that. Multiplied by 200 metres would be twice that speed. If it was 5 metres he swam, that's a tenth of that. Then it would be 4 seconds. It's a tenth of that. So whatever we multiply or divide one of these numbers by, we do the same to the other one. We say they are in proportion. So we can work out how long it takes them to swim 1 metre. And that would be dividing this by 50, taking a 50th of it. So we'd have to do the same to the 40 seconds. So whatever that comes to, that's the number of seconds it takes to swim 1 metre. And then we can move on to this 1,500 metres, because that would be 1,500 times what he's just swam 1 metre in this number of seconds. So we would multiply both of these numbers by 1,500. Now remember, you are allowed to use a calculator in this paper, but let's just see what we can do. Divide top and bottom by 10 and divide the top and the bottom by 5. 5 into 5 goes 1, 5 into that 15 goes 3. So we've got 4 times 300. Well, that's 1200 seconds. Now you'd easily do that in your calculator. 40 divide by 50 times 1500 and you'll get 1200 out. Now it says how many minutes does he swim for on Tuesday. Well, remember that 60 seconds gives you 1 minute. So we really need to look at 1200 and say how many 60s are there in that. And again, your calculator comes to the rescue. 1200 over 60, and that would actually give you 20. You can check that. So the answer to this question is 20 minutes. Now let's have a look at part B. And it tells us that this was a lie, what we were told, that he actually swims slower speed than he did on the Monday. Now in all this working out, we got 20 minutes by assuming he kept the same speed that he swam at on Monday, but we're now told he's swimming at a slower speed, so he would take longer. You swim slower, you take longer. Is it less than the answer? No. Is it the same? No. Is it greater? Yes, he will take longer. Instead of 20 minutes, it will be a larger number of minutes. So it's greater than the answer to part A. And it certainly is possible to say that. So here we have question 25. And we're talking about 4 people who take part in a TV talent show. And in particular, we're focusing on Amy. And we're trying to work out her total score. Now, there's a formula down here for working out her total score. And we're told it's 4 times the mean of her marks. That's this table up here. She was awarded 6 marks. There's 6 judges. Each judge gives her a mark, probably out of 10 by the looks of it. So it's 4 times the mean of her marks plus her percentage of the phone vote. And we're given information about the phone vote in the form of this pie chart, where you're told the degrees of each of the slices of the circle. So let's try and work out, first of all, the mean of her marks. Now, remember what the mean is all about. Mean would be the sum of all the marks. That's 8 plus 9 plus 9 plus 6 plus 9 plus 10. And it's that total divided by the number of marks that there are. And remember, there were 6 of them. Eight plus 9 plus 9 plus 6 plus 9 plus 10, and that comes to 51. Very nice just to write that down. So it's that answer divided by 6, and that gives me 8.5. So that's the mean of her marks. Now, we were told that it's 4 times the mean. So let's write that down. 4 times the mean would be 4 times 8.5. So it's that answer times 4. And that gives me 34. So what's next? Well, we have to find out her percentage of the phone vote. Now, you'll notice that her slice of the cake is 162 degrees. And all the angles around this point in the centre will add up to 360 degrees. That's a complete turn around that point. So her slice of the cake is 162 degrees of 360 degrees. So her percentage would be 162 out of the total possible degrees round there, 360. That's not a percentage. To turn it into a percentage, you multiply it by 1. Well, 1 in the guise of 100%. 100% is just another way of writing 1 down. So the calculation is 162 divided by 360 times 100. That gives us 45. So it's 45%. So what's her total score? Well, let's follow the recipe then. 4 times the mean of her marks, that's 34, plus her percentage of the vote, phone vote, that's 45. So we take 34 and add 45, do that in your calculator, you'll get 79. That's her total score. Well, here's question 26. And we're told that house prices on a certain street are increasing at 5.1% each year. And we have to show that after 14 years the house prices in the street will be at least double what they were. So let's have a wee look at a diagram. So the starting price, let's call it, we don't know what the house price is at the beginning, we'll call it P. So that's the starting price. And then we'll have various prices as we go after 1 year, after 2 years, let's put 1 more in, after 3 years. So the prices are increasing each year. And that goes on all the way along, and we're trying to find out what happens to these house prices after 14 years, assuming that they rise by 5.1% every year. So to get from the initial stage, initial price, to the price after 1 year, we're adding 5.1%. So we start off, let's have a look at what's going on, the calculation that would go on. We start off with this house price, and then we add 5.1% of that price. So that's the process that's going on to get from there to there. Same process that's going to get from there to there and so on. You're always adding on 5.1%. So if we start with this price, the whole of this price, in effect 100% of the initial price, and add 5.1% of that price, then what have we got? We've got 100 of it plus 5.1% of it. That's 105.1% of that initial price. 100%, that's the whole thing, plus another 5.1%. That'll be 105.1% of it. Now, what is 105.1%? You know that 105.1, the percent means divide by 100. And to divide by 100, we'll move that point 2 places to the left, or alternatively the digits move 2 places to the right. So we get 1.051. So to find 105.1% of that initial price, we'll take the price and multiply it by 1.051. And that's what we do to increase this price by 5.1%. The multiplication factor is 1.051. Now that we've worked all that out, we do precisely the same to go from this after 1 year to the price after 2 years. It's another 5.1% of this price to find the third price along the row here. So we'd multiply by 1.051 again. What that does is increases this price after 1 year by 5.1% to get the price after 2 years. And similarly, we multiply by 1.051 to get to the price after 3 years. Take the price after 2 years, increase it by 5.1% to get the price after 3 years. And obviously this goes on all the way along the row until we finally get to the price after 14 years. Now, looking along this line, we start off with this price P, we multiply by this, we multiply by that again, we multiply by the same number all the time. There's actually 14 of these, 14 terms. And if we take 1.051 and multiply it by itself 14 times, there's a very shorthand way of writing that, and that is 1.05 to the power 14. This little index up here means we take 14 lots of 1.051 and multiply them all together. That's precisely what we've got there. So we would take the initial price and multiply it by 1.051 to the power 14. Now, incidentally, you do get a formula sheet, and there is a relevant formula on that formula sheet. And it's to do with this. There's the initial price, and in the case we are looking at, the rate of increase was 5.1%. And it was for 14 years. So we're replacing R by 5.1 and N by 14. And that gives us 1.051 raised to the power 14. So it's the same as what we're doing here. This is an explanation of why that formula there works. Now, we're asked to show that after 14 years the house prices on the street will be at least double. So what are we multiplying this initial price by? Let's use the calculator to work out 1.051 to the power 14. So it's 1.051. Now, on my calculator, raised to the power, you should find out in yours where that button is. There's my raised to the power of button. And when I press that button, I get this little box up here, which is ready to accept this index of 14. So when I press 14, there it appears, 1.051 to the power 14. And that equals 2.006, etc. So what do we know about this? This number that we're multiplying the initial price by is greater than 2. And that's the crucial thing. The question asks us, show that after 14 years the house prices in the street will be at least double. So if you multiply the initial price by 2, you would have doubled the prices. This is slightly more than 2, so it has been at least doubled, so therefore at least doubled. And there's all the working to back up that claim. Okay, so here's question 27. We've got a couple of towns. We've got town A and town B. Town A and town B. Now, what facts do we know about these towns? Well, town A, we're told, the population, we're told is 84,000. And we're told the area of town A, and it's 7 square miles. That's miles with a wee 2 up there, miles squared, square miles. And what do we know about town B? All we know about it is its population density. That's how many people are living per square kilometre. So it's 4,695 that's people per square kilometre. Now we'll notice straight away that the measurements there are different. In town A we're told its area in square miles, and we're told the population density in town B in square kilometres, how many people on average live in 1 square kilometre. So what is the population density? Well, there is a formula here that the population density is given by the total population divided by the area. And the figure we're given for town B, remember the area was in square kilometres. We're asked which town has the greatest population density. So basically we have to look at town A and work out what the population density is. But there's a problem with this area, 7 square miles. We need to convert that so that it's in square kilometres. Now they do tell us the conversion that 1 square mile is equal to 2.6 square kilometres. So that would mean that 7 square miles, that would be 7 times what we're told. 2.6, 7 times 2.6. So that's 7 times 2.6. And there we have 18.2. That's 18.2 square kilometres. So I think we're all set to work out the population density using this formula of town A, because we know its total population, that's 84,000, and we now know its area in square kilometres, it's 18.2. So there's our next calculation. So that's 84,000 divided by 18.2. There we are. It's 4,615. That will approximate it to the nearest unit. So, which town has the greatest population density? So we've got a density of 4,695 for town B, 4,615 for town A. Town B has the greater density. Town B has the greater density. Since 4,695 is greater than 4,615. So it's town B, and that calculation is the justification for the answer that we've given. So that's Mr. Corsi signing out, and I hope you enjoyed the video.